All right, so today should be the second day of this Chapter 3 video series. So today should be Tuesday, March 25th. We're continuing on 3.1, talking about scatterplots and correlation. All right, so in this one, we have a scatter plot that is showing the relationship between payroll in millions of dollars, that'd be on the X, and then the wins for MLB teams in 2016. So for these data, the R value or correlation value is 0.613. Interpret the value of R. Okay? So the correlation of R equals 0.613 would mean that there is a pretty strong, so moderately strong, positive linear relationship between those two variables. Okay, remember R values range from -1 to +1. So the closer we get to -1 would be perfectly linear negative. Closer to +1, perfectly linear positive. Closer to 0 means there's a weaker relationship. Okay, so 0.613 would mean there is a moderately strong, positive linear relationship between payroll and number of wins. So the one thing you can't really tell from just interpreting this R value would be if there's any unusual points. So we don't mention that here because it says explicitly to interpret the value of R. All right. Example here with back to the track. So below, we got a scatter plot of the sprint time and long jump distance data from a high school track team. So the correlation was R equals -0.84. So the correlation of R equals -0.84 would mean that there is, again, a pretty strong, so again I would say maybe moderately strong, because the R value is negative, there is a moderately strong negative linear relationship between sprint time and long jump distance. All right, taking a look at that scatter plot. So sprint time on the X, long jump distance on the Y. So data kind of makes sense, right? The faster your sprint time, the longer long jump distance you have. Question here, what effect does the point that is circled have on the correlation? Well, if we drew a line through the center of these data, this point is pretty far away from this line. So with this point included, the correlation is weaker. So if we took this point out, then the correlation should get stronger. So turns out with this data point, it was -0.84, as we saw above. If you take that point out, the correlation becomes -0.87. So it gets a little bit stronger if you take a point out that is away from kind of that best fit line. All right. A couple notes on the bottom. Correlation does not imply causation. Correlation does not measure form, meaning correlation should only be used to describe linear relationships, not nonlinear relationships. And correlation should be used only to describe, again, a linear relationship. Okay, I'm just kind of hitting that home because a lot of people try to extend this R value to nonlinear stuff. It is only for linear relationships. All right, take a look at this next data set. So this is talking about Nobel chocolate. So most people love chocolate for its great taste, but does it also make you smarter? Scatter plot like this one recently appeared in the New England Journal of Medicine. The explanatory variable is the chocolate consumption per person for a sample of countries. Response variable is the number of Nobel Prizes per 10 million residents of that country. So we got scatter plot, we got an R value of 0.791. So a fairly strong positive linear relationship between chocolate consumption and Nobel laureates. So it appears that the more chocolate you eat, the more likely you are to win a Nobel Prize. But if people in the US started eating more chocolate, could we expect more Nobel Prizes to be awarded to the residents of the United States? Hopefully you're thinking no there. So no, even though there is a strong correlation between chocolate consumption and the number of Nobel laureates in a country, causation could not be inferred. We cannot say that if we eat more chocolate, that's going to cause more Nobel Prizes. What effect does Switzerland have on the correlation? Okay, so if you take a look back at that scatter plot, we kind of have this best fit line here. We drew it through the center of the data. So because Switzerland is so close to this best fit line, Switzerland is actually increasing the correlation, whereas these points out here like Sweden and Germany, they would be decreasing the correlation. Okay, so Switzerland is increasing the correlation. All right. Scatter plot down here. Following scatter plot shows the height in inches and number of steps needed for a random sample of 36 students to walk the length of a school hallway. Correlation is r equals negative 0.632. Explain why it isn't correct to say that the correlation is negative 0.632 steps per inch. Okay. Well, correlation is just an r value. Correlation does not have units. So it would be incorrect to say that it's this steps per inch. There is no unit label to that. Okay. All right, next one. What would happen to the correlation if number of steps was used as the explanatory variable and height was used as the response variable? So if we essentially took this height variable and number of steps and we switched the axes. Okay, well, obviously the y-intercept is going to change, the slope is going to change, but how the data are associated, the correlation, will not change. Okay, so if you switch the explanatory and response, a lot of things are going to change, but the correlation is not going to change. And then lastly, what would happen to correlation if height was measured in centimeters instead of inches? Again here, if you change things with these variables, if we go to centimeters instead of inches, the y-intercept, the slope, stuff is going to change, but how the data are associated, the correlation is not going to change. All right, let's go to the next page. So on this one, you might want to be pausing the video kind of throughout. We're going to take this data set and I'm going to show you the calculator how to make a scatter plot and how to get the best fit equation for this data set. Okay. So this data set, relatively small, talking about body weight in pounds and backpack weight. So if you had to make a scatter plot of this data set, you could do it by hand. Essentially, if you're going to make this by hand, that's probably easier, actually. For the x-axis, you can start it at different values. So because the lowest value is 103, we might start at 100. Highest value is 187, so we might go up to 190, and then section it off however you want to section it off. So I might go, I'm going to have to move this, I might go by tens, 40, 50, 60, 70, 180, 190. So label the axes, so this was body weight. Y-axis, backpack weight. Okay, again, that was in pounds. So y-axis wise, remember back to chapter 1, you don't want to start your y-axis at anything other than 0, otherwise it can kind of throw off the scale of things. So we want to start the y-axis at 0. Looks like the highest y value is 35. So we could probably just go up to 35. And again, we might want to count, in this case, maybe by 5s. 5, 10, 15, 20, 25, 30, 35, call that the top. Okay, so a scatter plot is essentially x-y axis, two quantitative variables, and it's just a point where you have this xy coordinate. So we have about 120, 26, about 187, 30, about 109, 26, about 103, 24, about 131, 29, about 165, 35, so that was the tallest, 158, 31, a bit lower than that, and then 116, 28. Okay. All right, so for what it's worth, it's probably easier to just make the scatter plot by hand after thinking about it. I do, however, want to show you how to run a regression in your calculator in order to get the best fit equation in the form y equals mx plus b or ax plus b, so essentially y-intercept form. So in your calculator, I'm going to erase this just so you can see the calculator. So in your calculator, you want to go ahead and go to stat edit and put those points, put those x values into L1, put those y values into L2. Okay? You might need to pause the video until you're at that point. Okay? Once you got them in there, we'll go second mode and quit back to your home screen. Okay, now this next step, you're only going to have to do it once, unless your battery runs out or something, or your RAM resets in your calculator. We're going to change a setting and it will stay changed unless what I just said happens. Okay? So go second 0 into the catalog. Okay, and it should pop up as alpha code up here. So essentially we want to go down to the D section. So you can either keep clicking the down arrow, or I would use the shortcut, and right above this x to the -1 button, there's a green D. If you click that, it'll jump it down to the D section of the catalog. Okay, and what we're looking for